Assalamualaikum and hello. We are from Group EMD5M66, Group 6. Today, we are proud to present the finding of our industrial visit for our course MEC 640, OSH and Manufacturing Technology. The purpose is to gather and present information about the company business activity that we choose, manufacturing process of how the product produced, and also the technology they use to make the product. Allow me to introduce our team from Group 6. Our members are Adam Muklis, Harid Hakimi, Nur Awatif, Nur Aina Fikriah, and Nur Amani Dayana. To ensure a throughout study, we have divided our tasks to cover company research and introduction, the manufacturing process in safety SOP, design concept and quality assurance, overall discussion, and last but not least is CQR, the continuous quality improvement. For this industrial visit assignment, we chose to visit Daikin Refrigeration Malaysia Sedihan Berhad that located at Jalan Utas in Section 15 Shah Alam. This company serves as a major manufacturing hub for their cooling technology product in Malaysia. Starting with the core business, this facility is a primary hub for climate solution for cooling, specializing in the manufacturing of high-capacity industrial chiller. Daikin Refrigeration Malaysia officially operated at this site in October 2018. Looking at the factory outline, the site is strategically organized into three main sections. The management building is for administrative and engineering support, Factory A, which is the chiller plant, and Factory B, which houses the AHU plant. For our industrial visit, we focus specifically on the operation within the chiller plant to gain a deeper understanding of the specialized manufacturing technology and safety SOP used in the chiller production. Daikin operates with a strict quality policy to ensure products meet customer expectation at a reasonable price. Their professional motto is "Do it right the first time," emphasizing that every employee is responsible for maintaining high manufacturing standard or SOP. Tracing the company's history, Daikin has seen significant growth in its manufacturing footprint. In 2015, their facility focused exclusive on air-cooled products. By 2016, they had successfully designed their own scroll chiller known as the UAM series. In 2017, they started to sell the UAM scroll chiller. A pivotal moment in their history occurred in 2018 when the company completed its transition from the original site in Sungai Buloh to the larger facility in Shah Alam, marking a new era for their production capacity and technological integration. Between 2019 and 2022, the facility reached several technological milestones. In 2019, they localized the manufacturing of in-house pressure vessel and established a 650 RT AHRI certified test stand. This was followed by the production of their first water-cooled screw-inverted chiller in 2020 and the air-cooled variant in 2021. By 2022, they produced the first 60Hz water-cooled magnetic barrel chiller and the first water-cooled screw chiller with economized, and they also have started to develop from the star delta power supply to soft starter. In 2023, the facility achieved a major milestone with the production of the first all-free water-cooled magnetic bearing chiller, a high-efficiency technology designed to reduce maintenance and operational costs. Following this, in 2024, they successfully produced the Japan standard water-cooled screw chiller and established a 200 RT AHRI certified test stand to ensure performance validation. As we move into 2025, the company is currently focusing on capacity expansion, including the development of all-bearing centrifugal chiller and air-cooled rotary inverted. This ongoing advancement demonstrate how Daikin consistently upgrades its manufacturing technology and process to overcome operational challenge and achieve better energy efficiency, directly reflecting the CQI principle we study in our industrial visit.
Daikin's factory is organized into a logical production flow. Raw materials move through dedicated zones, first to the pressure vessel stations, then to the chiller assembly, and finally to testing and packaging areas. Key technology used include CNC plasma cutting for precision, automated submerged arc welding for strength, and vacuum testing to ensure system integrity. Every chiller is validated using AHRI certified test stands, which simulate real-world conditions to guarantee performance before shipment. This streamlined layout minimizes handling, reduce delays, and support Daikin's commitment to quality and efficiency. Daikin produces its own pressure vessels in-house, which allow for strict quality control. The process begins with shot blasting to clean steel plate, follows by CNC cutting and rolling into shape, and submerged arc welding ensure strong, reliable seams. And each vessel undergoes hydrostatic pressure testing to confirm it can withstand operational stresses before receiving a protective paint coating. This vertical integration reduces supply chain risks and ensures components meet Daikin's high standards from the start. The chiller assembly line integrates various sub-assemblies into a complete unit. Key stages include the installations of compressors and heat exchangers, piping assembly, and electrical wiring. Critical steps like vacuum testing and leak detections ensure the refrigerant system is sealed and contaminant-free. Finally, refrigerant and oil are charged with precision. This methodical process ensures each chiller is built reliably and perform as designed. So Daikin's quality motto is do it right the first time. This philosophy is embedded in every production step to minimize rework and defects. Each chiller undergoes rigorous performance testing in AHRI certified stands. A final quality checkpoint before packing ensures only products that meet strict standards are shipped. This approach not only ensures customer satisfaction but also reduces waste and improves overall production efficiency. Safety is a priority at Daikin. All personnel and visitors must wear mandatory PPE, helmets, safety shoes, and vests. Designated walkways separate pedestrians from moving equipment like forklifts and overhead cranes. Mobile phone use is restricted on the factory floor to prevent distraction. Process safety includes logout and takeout during maintenance and strict protocol for handling refrigerants. Emergency preparedness is clear. There is a designated assembly point, safety briefings are conducted before tours, and evacuation routes are marked. These measures create a culture where safety is part of daily routine, protecting everyone in the facility. Daikin successfully integrates manufacturing excellence with strong safety practices. Their vertical integration and linear workflow enhance quality control and efficiency. This company's quality policies emphasize continuous improvement and shared responsibility. However, some risks remain, such as noise from shot blasting, ergonomic challenge in manual assembly, and hazardous energy during testing. Despite this, Daikin's embedded safety culture seen in clear protocols, training, and emergency planning shows a proactive approach to occupational safety. This balance between advanced manufacturing and worker protection makes Daikin a model of integrated industrial practice.
For our first point, let's look at the integrated design and quality system. Everything starts with the motto, do it right first time. This means they design the manufacturing process to prevent mistakes rather than just catch them later. We saw this in action with their in-house pressure vessel workshop. By making these critical components themselves in 2019, they control quality from the very first steel plate. Their quality assurance is a complete system with multiple checkpoints. They are in process checks during assembly, rigorous functional testing in AHRI certified test stands, and finally a dedicated last layer QC inspection before shipping. The AHRI certification is important. It's the industry standard that proves each chiller performs exactly as specified under real-world conditions. Moving to the products, they manufacture two main types of chiller. Water-cooled model offer maximum efficiency for large buildings, while air-cooled units are easier to install and maintain. What's impressive is their technology roadmap over the past decade. They start with basic screw compressor, advanced to screw compressors with inverter technology, and now produce cutting-edge oil-free magnetic bearing chillers. This use electromagnetic field to levitate the compressor shaft, eliminating friction and improving efficiency by up to 30%. They are also addressing environmental needs with HFO refrigerants like R1234ZE, which have minimal global warming impact. Looking ahead, they are developing centrifugal chillers for very large applications, showing they are strategically expanding their product range. Finally, let's examine the challenges they face in advanced manufacturing. First is operational complexity, coordinating the flow between pressure vessel fabrication, assembly, and testing areas, especially for custom configured units. Second is technology integration. When introducing something like magnetic bearings is not just swapping parts. It requires retaining technicians, developing new testing protocols, and updating all procedures, all while maintaining their quality standard. Third is scaling challenge. As they develop larger chillers, they need larger test stands. Their timeline shows continuous investment from 450 to 650 RT to new 200 RT test facilities. Their engineering solutions are systematic. They use phased implementation, breaking big challenges into milestones, vertical integration, controlling critical component in-house, and their quality first culture as their problem-solving framework.
For this slide, I will be discussing continuous quality improvement or CQI at the Daikin Refrigeration Malaysia Shah Alam factory. First, in terms of improvements to processes and products, the company can further enhance automation and digital monitoring in production to reduce human error. Strengthening in process quality checks will help detect defects earlier before final testing. Standardizing components across different chiller models can also improve consistency and reduce complexity. In addition, improving the factory layout can help achieve smoother workflow and reduce material handling time. Lastly, continuous improvement in energy efficient and environmentally friendly chiller designs will ensure the product remain competitive and sustainable. Finally, for better next, regarding problem faced and possible solutions, the wide range of chiller products increases production complexity. This can be addressed by using modular and standardized parts. Testing facilities may become bottlenecks during peak production periods, so better scheduling and capacity planning are required. Defects during welding and assembly can be reduced through increased automation and continuous staff training. Material handling delays can also be minimized by applying lean manufacturing practices such as improved layout planning and Kanban systems. Finally, for better efficiency and quality, the company should continuously apply Kaizen and the PDCA cycle. Monitoring key performance indicators such as defect rate, test pass rate, and production cycle time will help track performance. Encouraging employee participation in improvement initiatives can lead to practical solutions from the shop floor. Preventive maintenance should be strengthened to avoid machine breakdowns, and overall, the company should continue to emphasize the culture of do it right the first time to ensure consistent quality.
In this discussion, I will highlight the manufacturing process and occupational safety aspect that we observed during the industrial visit at Daikin Refrigeration Shah Alam. First, the manufacturing process at Daikin DRMSA is well organized and systematic. Pressure vessels are fabricated in-house using CNC cutting machine and automated welding, which improve dimensional accuracy and weld quality. The separation of air-cooled and water-cooled chiller line also help to improve the production efficiency and reduce the risk of process interference. So let's move on to quality assurance and testing. Quality assurance is emphasized at every stage of production. Pressure vessel will undergo hydrostatic and pneumatic testing. It is to ensure the safety of pressure vessel. So next, the vacuum and leak testing are performed before the refrigerant starts to charging. It is to prevent refrigerant loss and the system failure. So lastly, the product will undergo some testing, which is functional testing and AHRI certified performance testing. It is to confirm that the chiller meets the international performance standards. And it is to ensure the reliability when used in the real operating condition. Occupational safety and health practices are clearly implemented at Daikin. Some OSH practices are strictly applied in this company. For example, PPE usage and safety briefing for both workers and visitors are strictly applied to help minimize the risk on the factory floor. However, activities such as welding, lifting heavy components, and electrical testing still pose workers to the hazard. Next, the designated walkways are created to avoid the pedestrian from walking near the forklift and cranes. It is also helped to minimize the risk that could happen. Last, through hierarchy, the risk can be systematically identified and controlled. It is to ensure a safer working environment. So let's move on to the hierarchy form. The hierarchy assessment was conducted during the industrial visit. It is focused on the three fundamental components, which is hazard identification, risk assessment, and risk control. Hazard identification was carried out by observing critical manufacturing activities, such as welding operations, pressure vessel testing, material handling using cranes, forklift movement, and electrical testing of chiller units. All of it present potential safety and health risks. So next, risk assessment was then performed by evaluating the likelihood and severity of each identified hazard. It allowed the risks to be systematically classified. Most of the risks were assessed as a medium, as existing control measure reduce the probability of occurrence, although the potential severity remains significant due to the nature of the operation. Finally, risk control measures were reviewed, including the use of personal protective equipment, which is PPE, compliance with standard operating procedure, designated safety walkways, and the involvement of trained personnel. Additional control measures were recommended to further enhance workplace safety and ensure continuous improvement in occupational safety and health performance.